Hey everyone, on this lesson we will introduce the dataset that we will work with in this practice. The name of this dataset is Scraps. It is a CSV file. You can download this dataset on the downloadable resources of this lesson. So, in essence, it is a dataset that has the information of the crabs. It is taken from a paper published by Campbell. Campbell was a researcher that studied rock crabs in the 1974, mainly the rock crabs for the genus Leptograpsus. One species, the Leptograpsus variegatus, had split into two new species, previously grouped by color, orange and blue. So the preserved specimens lose their color. So it was hoped that the morphological differences would allow the museum material to be classified. So this is a practice about dimensionality reduction, right? We'll apply a technique, a method to reduce the dimensionality of this dataset. So on this lesson, we will introduce the dataset. We will see what are the columns, what are the features of this dataset, which information we have. So then on the following lessons, we can proceed with the technique. So the data are available on 50 specimens of its sex and species. So we have a 200 total crabs collected in Fremantle, Western Australia. So each specimen has the measures on, and here we have the attributes. The first one is the frontal lobe width. Then we have the rear width of the crab, the length along the midline of the carapace, the maximum width of the carapace of the crab, and finally the depth body length in millimeters, plus the color of the crab, in other words, the species, and also the sex. So now let's create a new notebook in Google Colab to start working. We already explained on the code environment setup section how we could create a new Google Colab notebook. So let's do it. We have just created a new Google Colab notebook. The name of this notebook we have set it to be Introduction to the Dataset. Later we will change and modify this when we start applying the dimensionality reduction technique. So first of all, let's load this dataset in the notebook. To do this, we will need to import some libraries in Python. So here, first of all, we are going to add a text window. Let's call it, for instance, import of libraries. We are going to use also here hashtag notation. When you use a hashtag in a text window, you are representing a heading or a header or a title, okay, depending on the title 1, 2, or 3, depending on the number of hashtags. We are going to put here a title 3. So here we have the import of libraries, right? So we are going to start by importing the pandas library. The pandas library is a software library written for the Python programming language for data manipulation and analysis. It offers data structures and operations for manipulating numerical tables and time series. So we will need to import the pandas because this data frame, this dataset crabs CSV, okay, we will need to import this as a pandas data frame, a pandas dataset. So we are going to work with pandas. That's why here the first thing that we need to do is to import the pandas library as PD, right? And now, since we also want to load a CSV file, we will need to import the input and output library. So we will be able to import and load files from our computer. So now finally, to be able to load files for the Google Colab notebook, we just here import from the Google Colab. We are going to import files like so. So now we run this cell. With this run, we have all the imports done, and now we can just proceed to load this CSV file. So in our case, you just go to this lesson on the downloadable resources, you go to the crabs CSV, you download this file. Once you have this file on your computer, here keep in mind that you have a folder in this directory of the Google Colab notebook. So here we just click it, this is the files that we have loaded. For now, we have not loaded anything. We just have the sample data that Google Colab provides to us. So to load this CSV inside this notebook, we will do this in a new code window. And we will do this with the files module upload method. So here we are going to create a new variable. Let's just say uploaded. This is going to be equal to the files upload method. So with this, we are able to load a new CSV or any other file that we want inside our notebook. So let's run this. We click run. Now, as we can see, this option appears to us, choose files. We are going to click here. And so it is going to open your file explorer in your operating system. So we just browse for the grabs dataset and we double click here or just click open. And now as we can see, we have loaded this grabs CSV file. We can just go to the files in the notebook and we see here the grabs CSV. So we are able now to work with this file. So now let's do an initial study and initial exploration of this dataset before applying any dimensionality reduction technique. We will do this on the following lessons. Now this is only an introduction to this dataset, so let's add here new text window and let's name this window the initial study of the dataset. So let's load this CSV as a dataset, as a pandas dataset. So to do this, let's name a variable. Let's name it grabs data, for instance, to be the dataset of the grabs. And now we are going to use the pandas and we are going to use the method read CSV with an underscore between read and CSV. So now we pass as an argument the name of the file, the name of the CSV. As we can see, it is grabs CSV, so we pass the name as the string. So this is grabs.csv. So now we can run this. Very well. So with this, we have loaded onto this variable. Now we have the data set for this variable grabs data. We can visualize the first rows of this data set with the head method of pandas. So here, if we just write grabs data head, with this, we can visualize the first 5 rows. So we have one attribute for the species. B stands for blue, right? The other option is O, that is orange. We also have an attribute for the sex, a feature for the index, a feature for the frontal lobe, rear width, carapace, midline, right, which is abbreviated with CL. Then we have the CW, which is the maximum width of the carapace, and finally the body length, which is here the depth body length, abbreviated with BD. And so we have this dataset, right? We have the initial dataset with the columns and their names. However, let's improve the understanding of this dataset before applying any dimensionality reduction. Let's rename the name of these columns. Instead of using the abbreviation, let's just use the total name. And also here for the values B, that stands for blue, M, that stands for male, and also here we can use the tail to see the last 5 rows in this case. Also, instead of O, that stands for orange, and instead of F, that stands for female, we are going to change this to map the values that is the total word. Instead of O, we want to see orange. Instead of F, we want to see female. And the same way, if we use here, we see the head. This gives us the first 5 rows. We want male instead of M, and also blue instead of B. So on one side, we want to rename the name of the columns and also change these values of this mapping for the columns species and sex. So something we have not mentioned, but here if we just write tail, this will give you the 5 last elements. Okay, keep in mind that you have a total of 200 elements. In fact, you can use here the shape. If you just run now, this gives you the dimension of this dataset. We have 200 instances, 200 rows, and a total of 8 columns. These 8 columns are, as we can see here, this 8 that we see, right? From the species to the body depth. So let's start by renaming the columns. So now we are going to rename the columns. To do this, we are going to update this dataset such that now the new dataset with the new name is going to be updated. We are going to rename the dataset that we have now, and we are going to rename the columns. So here we are going to only remain, in this case, rename and change the column names. And to do this, it is very simple and easy. We just here type a dictionary with the old value, which is the key, and the new value, which is the value of this dictionary key, right? So here we want to add species. This is going to change this column SP, which is this one, to species. The same thing we can do with the frontal lobe, right? These two we are not going to change because they are easy to understand, both of them. But now the FL, we want to change this FL. So FL is going to be changed and renamed to the frontal lobe. This is going to be the frontal lobe. Then the RW attribute is going to be changed and renamed to the rear width. This is going to be the rear width. And we can continue doing this for everyone. We change the name of this L to be the carapace midline, of CW to be the maximum width. And from the BD, we go to the body depth. Right, we're going to also change this and erase the last key and the last bracket. Let's suppose this from this until here in a new line, so you can visualize. Very well. Now we hope that now it is easy to see everything. We just change this older name to be this new name, this old name to be this new name, and so on. So now we are going to run this code cell, right? And now we are going to add now a new cell to visualize this change and verify that we have changed correctly the names of the columns. So again, we can just write grabs data head. The change has not affected the name, right? The name is the same. We run this cell, and now as we can see, the columns, okay, have updated their names. Instead of SP, we have species. Instead of FL, we have frontal lobe. Instead of RW, we have rear width, and so on. Now, the other thing that we wanted to do as well is to change the mapping between B for being blue, M for being male, and in the same way, if we check the last ones, instead of O, we want the orange, and instead of F, we want the female. So now, instead of changing the names of the columns, we want to change the mapping for the values. So the way to do this is the following. We access the columns that we want to change. In this case, first we want to change the species, right? So here we just type species. We want to change instead of B to be blue, instead of O to be orange. So we are going to update this column to be the grabs data species. But now we are mapping, and this is important, here we are adding a map because we are changing the values, not the names of the columns. And again, here we pass a dictionary as an argument. Here we have the old value, so instead of B, we want to have blue. Instead of O, we want to have orange. Right, this is an O. And the same thing stands for this feature, this column of the sex. So here we access this column, data, with the column sex. We are going to update this column to be a mapping. So again, we access this column and with the map. And now instead of M, we want to be male, right? So here we change for male, and instead of F, we want female. So we just change this to be female, like so. Very well. So now let's run this code cell. Once we have run this, let's update this grabs data head and verify that now the values are changed. So we run this, and as we can see, we have precisely done that. Instead of B, we have blue. Instead of M, we have male. And if we check the last elements in this data set, the last instances of the grabs, instead of O, we have orange. Instead of F, we have female. Pretty easy, right? Very well. So once we have introduced to this data set, the objective of this practice is to separate the 200 grabs that we have in this dataset into 4 different classes, 4 different groups or 4 different clusters, right? Given by their sex and given by their species. So we can have one class that is male blue, another it is male orange, then we have another female blue, and another female orange. So we have 4 classes. And we will need to do this with a dimensionality reduction technique. So let's add here a new text window, and now let's paste here the objective. So here the goal is to separate these 200 instances of grabs into 4 classes, right? And this is what we are going to do on the following lesson using the dimension reduction and the dimensionality reduction technique of this section. See you on the following lesson.